Hello, good morning, good afternoon, and good evening, and welcome to today's webinar, where we'll be discussing managing workloads in a multi-cloud environment using Automic Automation. My name is Scott Wilson. I'm going to be your host and moderator for today's session, and Dave Kellermanns is going to be our speaker. Dave Kellermanns, as you can see on the first slide, is our Global Automation Advisor for the Enterprise Software Division of Broadcom. Dave has worked in the past for a variety of Fortune 100 companies in reviewing and strategizing around automation strategies and tactics, starting with innovation for behalf of the business and with the strategic efforts and tactics to actually drive great value at companies. As these companies need to automate at a rapid pace in order to innovate, it's been his role as the advisor here at Broadcom to help companies grapple and put a framework around the big picture and automating and addressing the automation silos and overcoming some of the challenges and obstacles in an effort to get that efficiency and to overcome a lot of the manual processes and automate, I should say, the manual processes that exist in IT, as well as forming that broader sense of orchestration that crosses many channels. So, with that, without further ado, I will go ahead and turn this over to Dave. When he is done, I'll open it up for questions and answers. If you just answer your questions to the right-hand panel, we'll get those answered after the session. Dave, you.
Thank you so much, Scott, and also a warm welcome from my side. As Scott said, my name is Dave Kellermanns. I've been with the automation team for 21 years now. And this session is actually a continuation of a session a few weeks ago that was going more into the theoretical concepts of moving to a cloud. And one of the feedback we got from the large audience that was there was to see a technical presentation, how this could possibly look like. So this is that session that you guys asked for. With that, I quickly want to level set for the people that haven't seen the first presentation. As you probably are aware, Broadcom has a very global approach to automation. We don't think about delivering just a point automation tool, like creating another silo, but it's really about helping our customers adopt an automation center of enablement approach. It's really changing the way you perceive automation into an enterprise capability, holistic automation where people have an automation-first culture that encapsulates things like reusable blocks. We actually talk about them today as well with an ecosystem you share throughout the organization. It's also not about replacing your tools, so throwing everything away, but it's really integrating them and creating the way to orchestrate existing tools with new capabilities and features. As you can see around the slide, there's a lot of different use cases. Today, we mostly will talk about multi-cloud automation. And with that, let's actually dive in. So one of the things we see a lot when we talk with customers, whether they're small, large, global companies, they are starting to move into the cloud. And as you move to the cloud, you really have to figure out, okay, so what cloud vendors are we using? Are we using a platform as a service? Do we really get out of the data center business and run software as a service? And how do we move what we are doing today on-premise, the workloads, and transforming them into the cloud? And so sometimes that could be technology changes, feature changes, but it's really a bigger discussion when you do that transformation to be a cloud company or a company that relies on cloud infrastructure. So what's really the biggest challenge? And personally, I think that's really the moving the critical processes into the cloud and having a certain level of comfort when you do this. So what does it mean really? Do you have visibility into the processes? So do you know for your most critical processes what goes into them end to end? Are there different tools, automation processes that you're using that need to be now connected in the cloud? Are there manual steps or manual handovers you have? So how do you handle what you're doing today on premise and move it into the cloud? So in today's session, we're actually going to talk about two different use cases. The first one I call moving day, and moving day is really about moving a defined set of workloads or tasks into the cloud. Personally, I think this is the bread and butter part, and then the second one will be a lot more about what's possible. So to explain what we do, what you're going to see, we're going to have an on-premise system. Keep in mind, whenever you see a blue background, that's actually a server in my data center. So that's on-premise. And that will be running workload, not very complex workload, but workload on-premise. And then whenever you see a black desktop, that's actually the cloud system. So the first step, what we're going to do is we're going to take our Automic node or agent or executor, depending what version you run, and we're going to move that into the cloud, and in that way, just shift the workload. So it's basically, that's why I call it moving day, taking the workload from an on-premise system and moving it to the cloud. So let me actually switch to screen share so you'll see a little bit of what's going on. And then we'll move away from that screen because otherwise you get that screen and screen and screen. So for those of you that know Automic, this is your standard current version of Automic. It has the dashboarding capabilities, assembly, monitoring, administration, and as such, nothing really special about it. The other thing that I want to point out is I do have, remember, blue background here. I have a sales records. That's a set of CSV file with about 1,001 rows of sales records. And then I have my workload. That's the data muncher batch file. Really behind the scenes, all it does is a row count in this version. That's it. We're not going to focus on what the workload is, just that there is a workload. And then you can see here, you have an Automic instance with a data muncher agent. So if we go back here and go to the administration panel, agents and groups, you'll see there's a data muncher. It is on a local IP address, nothing like localhost, and it's just running a standard agent build. So if we run this job here, let me actually open this up so we can see it. It's just a standard job. It runs on the data muncher with a login, and it runs the data muncher process. So not really something special, but if we execute it, you will actually see it. And that normally, and if we look at the last report, you'll see it does a simple row count. So right now, on-premise, my workload is to go through the sales records and understand how many rows are in there. Now, that could be a whole order to cash, billing process. It doesn't really matter for us what the insides of the workload are. So how do I now go about moving day? How do I take my workload and bring it into the cloud? So the first step we're going to do is we're going to take the data muncher, there we go, and we're going to stop it. And I'm doing a few things inside the specific tool set, like the service manager, just so you can see what I'm doing. I could also do this in an automated session. We'll talk about that a little bit later. And then I take my data muncher agent here, and easiest way to do this would be just to create a compressed file. So you can see here I have my on-premise zip file, and in there I should probably show you this for simplicity's sake. In there I actually have the data muncher, and probably the more interesting thing in terms of Automic capabilities, I have a fully qualified domain name to the server plus the port. So fairly standard configuration in Automic's world. So we're going to take the on-premise zip, and just like any good cooking show, I prepared that because we're not going to watch me copying a file. So this is the black background. So now we are actually on a server that's hosted in Google Cloud. You'll see I have the on-premise zip file here. And you'll also notice right now I have pre-installed a few things like what's called a service manager, so we can control the agent remotely. But at the end of the day, you see the Windows folder here is empty. That's where the agent will reside. So if we open up our zip file here on premise and just take everything that I took from the existing server and move it in here and do a paste, so nothing really fancy, then I basically can go to the service manager in question and start up the data muncher. So you can see it's running. If we look, as you know from other Automic components, everything is logged. It actually found the Automic system via the address. So notice I did not change the address. It does the IP based on that. And if we go back to Automic, you can see the data muncher ended. That's what we did on the one side, and now it's active. If we go back to the administration panel, you'll notice the IP address changed. So this is now a public IP address out on my Google Cloud server. And if we go back here and submit this job, then you'll see it behaves as if nothing happened. We all know I just moved it to the cloud, but it's running this now on the cloud server with the cloud IP. And that would be a first step moving to the cloud, taking an existing agent and putting it onto a cloud server. Now, if we go back to the slides, you'll notice that the arrow is pointing from the cloud to on-premise. And that's potentially the other consideration when you move to the cloud. So by default, an Automic agent makes a connection to the server. So if you leave the server on-premise, you're basically creating a connection from the cloud to on-premise. And what that means, for most of you, you'll be painfully aware of that, is things like a firewall needs to be opened on specific ports to specific IP addresses where you are hosting the engine and things like that. And so what customers actually are looking to do when they move to the cloud is they actually look at deploying something that comes with Automic called a proxy server. And what a proxy server can do for you is it can reverse the communication direction. So in this case, what you'll see is I will be spinning up on my cloud system a proxy server, and then I will use a proxy client on my on-premise system to build a communication tunnel. And when I do this, the Automic node that we moved, so the data muncher, will actually just connect locally to that proxy. And that becomes particularly useful when you move a lot of your agents up into the cloud. Because now what I can do is I can have one or two or a multitude of different proxy server and client pairs and make connections locally within the cloud versus connecting across the network. So, for example, if you had certain servers in GCP, certain servers in, let's pick AWS or Azure, or all the cloud providers, you can actually create these client server pairs and build local connection points for that. So let's actually look how that looks like. I'm going to go back to screen share. We will, we'll go here in a moment. So this is, remember the dark color here, this is the cloud server. We're going to stop the data muncher because it is connected through the internet into my system. And I already installed the, oops, there we go. I already installed the proxy. It's the same binary for both use cases. The difference is that when you start a server, you actually need a Java key store that contains your certificate, could be self-signed, could be any other certificate, to create an SSL tunnel between the components. So if we go over here, you'll see I already switched into the directory. I'm going to do a select. Okay, so I'll cheat a moment here. I'll grab the command that we need. So you can see here, it's actually opening up the proxy server. Here's the key store, the password obviously encrypted, and then you can define the service port that you want that this would run on. So really, there we go. So I have a little bit of trouble with the pasting right now. Okay. This is the nice proof that it is a live presentation. There we go. So when I start this, what basically happens is it's spinning up the proxy server. It loads the certificate to create an SSL tunnel, and then that's basically what it does. So normally you would run this if you are doing this for a single server. It would potentially be in the service manager, but then we wouldn't see all this. Maybe that's the reason why I'm doing it as a command line. And if you're running multiple cloud systems, then potentially you might have one or two proxy servers, small servers, that would be running just the proxy to build the tunnels, and you can run tens of thousands of agents through a single proxy, so it's really scalable. So I've started a server. Now I'm going to go back to my on-premise version here. Same concept, already in the right folder. You just grab the copy buffer. You'll notice here the command is a lot simpler to start this, because all this tries to do is it tries to build up a connection. So if we look at the connection information or the config file here, you would actually see I specify where it will find the cloud server on which port. So if we do this and start here, then you'll see not much happening here. You'll see down here we get the little icon going. But if we look at the cloud server, you'll see now it has an incoming connection. So basically what now happened is I have a tunnel secured by SSL between my on-premise instance and this cloud server. And so now what I can actually do, which is fairly neat, is I can go to my Windows server, the data muncher, change the configuration settings. So I'm going to edit it real quick. And where are you? I already scrolled by. There we go. So this is typically my DNS name, but I can now say localhost, save this. And so now what happens is when I run the data muncher agent, it behaves just like before, except for now it actually created a connection to this proxy server here. And the proxy server routes the connection over into the on-premise network. And if we look at the proxy server log file, you'll also see here I have an agent that actually now connected. So if we actually go over back to Automic, oops, one more, and I run this job, then it behaves perfectly normal. You can even see the proxy server as part of the agents and groups, so you'll see where it is going. And that's really, I think, another part of this is to actually go ahead and use the proxy because it gives you that secure tunnel. It gives you also a way to coordinate where the agents connect to versus having every agent cross the internet or whatever communication channel you have into the site. So that's really use case one. That's what I call moving day. You pack up your critical processes and infrastructure pieces that belong to it, move it into the cloud, and that's obviously a lot easier when you have the visibility that, for example, Automic provides you. So with that, let's actually move along. And so one of the interesting things, and for those of you that attended the first webinar, if not, you might want to go back to it. One of the things that Gartner found in one of the recent surveys, and the thing we're going to focus on is 81 of the organizations that they sampled have at least 2 or more distinct cloud providers. And that's, I think, an interesting statistic, because what it means is you not just have to figure out one cloud provider as part of your cloud strategy, you have to provide or figure out 2 or 3. And there's usually a benefit to each individual one, whether it's cost, machine size, availability, you name it. There is a reason why they have 2 or more. So let's actually look into the second use case, which I call a tale of 2 clouds. And this one needs a little bit more explanation. There's a couple more things on the shopping list there, but we'll work through it together. So we're going to start with 2 cloud providers. In my case, I'm using AWS and I'm using GCP. And right now, in those cloud providers, there is nothing predefined. There's no machines running that pertain to this use case, or workload defined, or images. We're going to use very blank Ubuntu machines that we've built on the fly. And so in this use case, what we'll do is we'll actually build an Ubuntu server on AWS for small data. And then we actually going to run the exact same use case, but we're going to run it with big data. So what we want to do in this use case is then build the same server on the second cloud provider that might have a different cost structure, a different technology behind the scenes, whatever the reason is why, if it's bigger data, I'm moving it to the second cloud provider. And then at the end of the use case, we want to have nothing left. So the idea is I can actually build workload on the fly, pay for it when I use it, but when I'm done using it, I can just get rid of it again. And so you pay what you use the best cloud provider for the job. And if that decision criteria changes, you also want to be able to quickly switch out the way it works. So with that, let me explain some of the pieces. We're going to actually look at the Data Drives Cloud use case here. I'm going to show you quickly my Google Cloud Platform. Let me refresh that screen. You'll see here I have a filter. We actually don't need this one anymore. This was for earlier. But you see here there's a big sales data filter. And then you'll also see I have an EC2 system with nothing in there. So just like a good magician, the hat is currently empty. There's no rabbit in there. So for this use case, it'll be interesting or important, should I say, probably we can actually close a few of these things because we won't need them anymore, what kind of sales data we have. So remember, as I said earlier, this 1,000 and 10,000 doesn't matter right now. Well, now it will. So this is my 1,000 sales records data set, 123 kilobytes. That's currently in this location here. So when we look at this workflow, you'll see it has actually a couple of capabilities. So the first one here is the sizing the data. So this will find out, is it small data, is it big data? The way I look at it is, if it's less than 5,000, it's small data. If it's more than 5,000, it's big data. And you'll see here in these 2 spots as well as here is an action pack Automic delivers. So action packs are predefined capabilities. There's hundreds of them in the marketplace. And our idea is that you don't have to necessarily learn all the things you need to learn about GCP capabilities, AWS capabilities, how to create ServiceNow tickets, how to update things, how to run your Ansible, Chef, Puppet scripts. These are all actions that you can use. But what Automic delivers, and this is the crucial piece for this capability, is we deliver something called an infrastructure manager. And an infrastructure manager is a REST-capable API that can build servers remotely using behind-the-scenes Terraform capabilities. So if we look at infrastructure manager here, you can see I can create infrastructure, I can delete infrastructure, I can get execution logs from infrastructure, so a lot of different capabilities. And we'll actually have a look at one of them. So here you see, here's my create infrastructure, and if I look at the properties, you basically pointed to where you installed infrastructure manager, so the REST API. You need to authenticate against infrastructure manager, given what capabilities it has, probably a good idea. And then in here, and let me close this for a moment, you'll actually see parameters that we need. So what's the infrastructure name? Who's the backend provider? So in our case, for example, Terraform. And then what is the infrastructure provider that Terraform will use? And we're going to use AWS in this case. We'll see here it uses a repository for the description of how to build an AWS service. And then here we'll talk about in what folder of that repository is that specific capability. And you'll see basically with logic, preconditions, if the data size is less than 5,000, run the AWS server. Otherwise, skip that, not enough horsepower. If we go to the GCP one, you'll see the reversal of the sign here. And you'll see in the prompts, it has Terraform. It actually will override a few variables. We'll talk about that in a second. And then it has a lot of the same things, except for this is logging on to GCP for me. And in the same repository, it's using a different folder. So as this will take a little bit to run, I'm not going to show you all the pieces yet. We'll work through them as we wait for the server to complete. So let me close this. Let me open up my messages again. So if we run this workflow, right now the data file has 1,000 lines in it. It will pick this line. And because it is a new server, it also in the script has a provisioning of an agent. So as this will run, it will actually provision an Automic agent on the fly with a dynamic name. And then when that is completed, it will move the sales data from my on-premise file storage, database, wherever. It will move it into the cloud on that newly built server, and then it will process the data. We'll do a work count, a row count. We might check for duplicates, things like that. And then when it's done processing the file, it will actually delete the infrastructure. And by the way, if you're wondering why the delete infrastructure doesn't have 2 build-outs, it just needs a number it gets from either one of those, and then it deletes the infrastructure. So when we run this, let me execute it. Let me open up the monitor. You'll see it actually sized up the data already. It actually skipped the GCP, so it does know it's small data. And if we go in here, you'll see it creates infrastructure based on the steps that I gave it, and then it gets the execution status. So now we have a little time to look around. So what I want to show you first is actually the GitHub piece. So what's this Terraform language that it refers to? So here you'll see the GitHub repository, and in the second step, I'll show you where you define things like this. And you'll see I have different templates here. I have AWS, Azure, GC, VMware. There's pretty much a Terraform language for all of them, whether it's you need a Docker container or anything. But if we look at an AWS Basic Template, you'll see here I have a few variables that I'm passing. So login information for AWS, which AMI to use, what's the security group, so maybe if I need ports, I can open them. And then basically I say, here's my AWS provider, and here is the instance that I want to build, and the name is some tag that I provide to it. So very basic language, not a lot of specifics in there. And I can basically build an AWS server on the fly, or I can even go ahead and use something, so a lot of it the same, and use something called a provisional concept. And what a provisional concept does is it basically is something that I do to the server once it's up and running. So once the server is up and running, I'm now going to produce an agent onto the machine, and then I'm going to customize the agent. So I'm going to give it a random name, a specific port, the automation engine system name, a host, port, service manager. I'm going to give it in the configuration file its own IP. And the way I get into the server is by that public IP, SSH with the Ubuntu user ID and the key file. And so these templates are open, so we even give you a default repository. If after the session you would like to clone mine, feel free to do so. And then you can see down here is the same for Google. So we look up, you will see this actually already ran through. So let's have a look in the messages what happened. So it got execution status. It created a host. So this is active now. And then it takes a while for Terraform to complete the process, and the interval on how often it checks is customizable. I didn't show you this. There's a few settings below. But now it actually finished the workflow, so it built the Terraform server. Then the next step, if we look at executions, it actually went and moved the sales data. So you can see here's my 1001 records that were transferred. And if we go one step further in the config here, and I go here and I show executions, you'll notice here's my job, open report, and it's on that new agent, 1,000 records, perfect. About 3,000 words, here's a header row, and if I would have a duplicate, then it would show up down here, which we don't have in this data. And then, after the fact, it actually destroyed the infrastructure. So you can see here the server ended, and if we actually look at the administration panel, I didn't delete the agent, so I can show you a few little things. Here's the agent, it's down. You'll see here it actually is on AWS. And if we go over to AWS, let me refresh the screen. You will see here is the small sales data. That's an instance we brought up, and it's already terminated. So really, I only paid for the couple of seconds that I needed that machine and was running the data. So small sales data, obviously not an issue. This runs on a free tier of AWS, so I didn't really pay anything for the probably not even 5 minutes, 2 minutes, the machine was up and running, and now it's gone again. So let's actually look at large sales data. So if I copy the file, so same location, you'll notice slightly bigger file, and we run the exact same workflow, again, monitor, you will see it now decides, oh, I need to run GCP data. Now you could have a variable behind it for cost, any kind of way to make up the decisions. I just went with sheer counting the rows. And again, you'll see now it runs the GCP template. So while it's actually running, there we go, we'll see the server here. But I also want to show you a little bit behind the scenes of the infrastructure manager. And for this, I'm using Postman just to incorporate the REST calls. So this is basically if I wanted to communicate with the infrastructure manager on a REST level. So you can see here are my two infrastructure providers. They get created via post calls. I can see types of infrastructure I can provision. So here are all the different ones. You can see Alibaba, Azure, Google Cloud, VMware, things like that. I can also see the executions, so here you can see is the current running one. Let me actually show you the finished one. Oh, let me show you the running one. So I can go in here, I can send this over, I can see how it starts, and then you see down here it creates a random name, it creates an instance, and once it's done creating the instance, it switches over to the provisioner. You'll see it now tries to connect to the instance. All of you that have worked with those systems, you know it takes a while for an SSH service to be up and running. So about 30 seconds later, it was able to connect. It creates a working directory. It uploads the artifacts. Now it starts an install script. It lays down the binaries. It creates a symlink. And then you can see here it's still creating. And if we would keep on querying this, you'll see, oh, there we go. It finally ended, and the agent is up and running with the random steps. So if we go back to Automic, you'll see here, again, it finished building the server. It then copied the data, and if we look at the executions, you'll see here, open report, it transferred the much, much larger file. It also went and, there we go, did my processing of the file. So now you can see 10,000 rows plus a header row, a couple more words, nearly 30,000, and my header row. And then it went and deleted the infrastructure. That's one minor difference on GCP is it disappears directly. So if I refresh this, you'll see it's gone again. So just like the AWS case, you only pay what you use for, or what you use, and you can easily build servers on the fly as you need them or as the need arises. So with that, let me go back to my slide deck. So really, that's why we feel a holistic automation solution can give you a lot more capabilities and build a much stronger use case for moving to the cloud. Because first of all, you will be able to move the workloads to the cloud with confidence. Just like what you see me do in the first use case, it really is something that you pack up your pieces, you go. If I wanted to, I even could have created an object to move the batch file and the data that it's created. So it really gives you that confidence to move. The other part that I think is a benefit that we didn't demonstrate today as much is really the ecosystem. So as you probably know, Automic runs on the mainframe, on distributed systems, on a mix of systems, and what you saw a little bit in the use case in a multi-cloud type of setup. And then last but not least, it also is built to scale. So just like I built an individual cloud server for the use cases on AWS or on GCP, the Terraform language does actually give you the capability to say how many nodes do you need, how many do you need to spin up. So if you realize that on the first cloud provider, you need a single machine because you're only processing a very small amount of data, but on the second cloud provider, maybe the distinguishing feature is it handles multi-node clusters better than, and I need to spin up 10 to process the same concept, then that's actually just 2 or 3 lines in Terraform, and any variable you expose to the outside can actually be set by the action pack in Automic, so that you could also spin up 5 servers and process the same data on 5 servers if that's what you need. But really what it gives you is the ability to scale across multi-clouds to get away from a lock-in into a single cloud, and that's really what it is. So I hope you enjoyed today's session with a live component, and I apologize if I moved the screens a little rapidly, so you got a little nauseous between the blue screen and the black screen, but I hope you found it interesting. With that, I'm actually going to open it up for questions. As Scott said, there is a question panel that you can go and type in your questions. And with that, I would ask Scott to moderate the questions if he could.
Thank you, Dave. We do have a few questions. So the first question is, so how does the proxy server help with security concerns? And if so, how?
Right. So the proxy server itself creates a secure SSL tunnel. So that's the first part, because in the first side of the use case, I was just sending the data using AES-256 encryption, but I used the internet to, just a standard internet, to move data between cloud and on-premise. What the proxy server does is, first of all, it creates a tunnel. So it builds an SSL tunnel that encrypts the data between source and between server or client and server. The second part is I'm actually need a lot less firewall work, because typically if you have an inbound connection into your network, you need the firewall guys to open up ports. With a proxy server, you streamline or you bundle all the communications of the outside agents through this one tunnel. So even if you had an inbound-outbound firewall rule that you needed, you would only have to create it for a single port and not for every port, every IP the agent NSCP lives on, because now you're bundling through that. So security through SSL tunnel with your own certificate, and being able to keep the firewall a lot closer in terms of number of ports and IPs that you need to authenticate to. Good question.
Perfect. Thank you. Okay, so next question. Can the agent run in a container?
Yes. So, and this is a larger discussion, right? This could be its own session for argument's sake. So the agent is a single binary, right? At the end of the day, it's that single binary you run. So the first question I would have, why are we trying to run it inside a container? That would be part one. Part two is, though, yes, you can if it's a supported container like an Ubuntu container or things like that. But you can also manage containers from the outside. So, for example, if Docker would be the provider, you can do a Docker exec, and that way you can actually get from the outside into the container. So there would be the potential benefit to doing that, because then you keep the container smaller and functionally defined. In either case, there is an action pack available. So this is the beauty of the action packs. You go to the marketplace, you look for Docker or Kubernetes, you download an action pack, and immediately you can choose whichever strategy you want. But yeah, so first one is, why would we containerize the agent itself? And then the second part is, if we do it, do you rather want to go from the Docker host inward, or would you rather be inside the container itself, and then you have to deal with the network pieces and things like that?
Perfect, Dave. We got another question. It says, am I understanding this correctly? Can Automic help me reduce my cloud costs? Yes.
So this is actually one of the things that you saw me do, and when I built this initially, in its first iteration, I was content to build the server and be done with it, right? Build the server, and what happened was I had what we would call a cloud sprawl. We used that term a long time ago in VMware sprawl. You know, everyone starts building VMwares on VMwares on VMwares, and suddenly you have hundreds of VMware machines that have never been used again. And I said, wow, I have now 10 AWS servers. I wonder if that's still free. And that's kind of the thing, is if you build these cloud servers and you have an easy way to remove them after you're done processing them, about processing the workload, then you do reduce your cloud cost. You also reduce the number of VMs you need, because at this point, you would build it when you need it. And as you know from today's demo now, it's really something that builds a cloud server in 2 minutes, and then destroying it takes maybe half a minute afterwards. So it reduces your cloud cost to what you really need for your critical processes. And when you're done, you destroy the server and you build up a new one when you need it again, especially for tasks that you execute maybe once a month or once a year. That obviously adds up really fast, because even if you don't pay for the run, you do pay for storage or for the hard drives, things like that. So yes, it definitely will bring down your cloud cost.
Perfect. Okay, one more question. It looks like it says, this has to do with your statement, just reiterating that Automic can run on the mainframe. It says, will this open source project, I think that's Zoe, will it reduce or eliminate the need to install something on the mainframe for Automic? Reduce or eliminate doing that?
Again, probably a very different whole session thing. So for those of you that don't know and have a mainframe, Zoe is an open source capability to expose capabilities on the mainframe to developers and operations on a distributed environment. So Zoe runs on Windows, Linux, things like that. Broadcom was actually one of the main contributors and drivers behind the project. And what it does is it actually has a lot of capabilities that are beyond just running jobs. So you can manage KICS regions. You can start and stop started tasks, things that today you probably could do with a lot of coding. But here it's a single command line, and we build an action pack to make it even simpler. So what it does is it opens up the mainframe to the outside distributed world and give you more capabilities. One of the prime features that I think with Zoe is featured quite prominently is when you think about remediation. So if you have mainframe operational intelligence that reports into AIOps, and you might have an issue with a started task and you need to restart it, then Zoe can play a really great role with Automic to just get the alert, restart the task, and things like that. So you don't have to install anything, and it really gives you a lot of capabilities.
Excellent. Looks like there's a follow-up question to that, Dave, which says, awesome. Would then, in your opinion, Zoe potentially help you treat the mainframe as another remote target?
I don't want to do any disservice to the mainframers. There's obviously a lot of things that are really amazing and special on the mainframe, but it does become a target in distribution of software or coding or things like that, and it makes it much more openly accessible in a secured way. Don't get me wrong, but to new generations of programmers and operations that maybe have not started their life in the TSO section on the green screen.
Perfect. All right. Well, we really appreciate all of your interaction and your questions. If you have additional questions, we'll get those and follow up with you. We appreciate your time, Dave. Thank you, everyone, for joining, and have a great day.